We welcome everybody again tonight to the Radio Club for June 2021. Stephen Slider is going to start off real quick and give us a quick update, I'm sure, on repeaters. So let me hand it away to him, and then we'll twin it over to Rob for the program.
No. All right. So as some of y'all know, we have deployed the Vertex repeater that was modified, and we connected it to the main RLC controller. So we have Echo Link back, Skywarn back, and the Southeastern Link repeater net back, and linking to 220 during the Sunday night net. So the repeater is working absolutely marvelously. And I think our coverage has somewhat improved, and actually I know it has just by where I'm able to hit it. So very good things are happening. We've still got to get the original Vertex modified in the same way so Mike Miller can have his Vertex back, but we're going to be working on that very, very soon, I hope. I need to talk to Mike about that, and that's really it.
Okay, Stephen, thanks. Stephen's been hard at work trying to get things up and running perfectly, along with Jeff. They've been hard at work going back and forth to the tower and have made great strides. So thanks for that, Stephen. And I'll, at this point, as a reminder, there's no Hamfest this weekend because of COVID and our inability to use the facilities that we normally do. Just in case you haven't put that on your calendar, no Hamfest this weekend for us. And I'm going to hand it over to Rob at this moment, let him get carried away with the program for tonight. You'll have to unmute, Rob.
Oh, okay. There I go. There's me. Yeah, I want to welcome everybody, and we've got another great speaker. We've been having great speakers through the because of Zoom. I think I'm a little worried when we start meeting in person again that certainly the speaker pool will diminish. But while we're getting great speakers from around the country, I'm very happy to say that we've got K7SYS Dr. John Klute on tonight. From Idaho near the Canadian border. He used to be in Atlanta. I know him from Atlanta. He was very active in Atlanta. He was very active in satellites in Atlanta. He was, to me, the Atlanta satellite guy to go to. At our Hamfests and Stone Mountain Hamfest, he'd be there every year with a trailer with satellite antennas in it. And then inside the building, he'd have a working, he'd have his radios there, and he'd be able to give you demonstrations or, try to give demos right there of all the satellite technology. So he is definitely the satellite guy. I know he's some more than that. I know I've heard stories about EME, but he's also director of operations for ARISS, which is the national group that connects schools or gets schools, organizes schools to talk to the space station. Space station talks to about 20 schools a year, and ARISS is the one that sets up the schools, and John's very active in that. So with all that, again, I'm very happy that he's here. Let me pass it over to John Klute. Good evening, John.
Good evening. How are you? And let me think if I can get shared screen to work here now. So I don't know, are you all seeing a screen or did I do it wrong?
You got it.
I got it. It should say ARISS update and into the future. And thank you, Rob. Yes, indeed. Up until after 30 years, we finally moved to Sandpoint, Idaho to be closer to kids and grandkids. And it's kind of, one of those things where I guess you got to do it at some point in life. But boy, I sure miss you all down there, because it's like I know lots of people in Atlanta. You may know me as K4SQC. That's my call when I was down there. And so up here, K7SYS is actually my old call that I got when I was a novice in Seattle as KN7SYS back in 1962. We've talked about a lot of things over the years. We've talked about how to work the satellites. We've talked a little bit about AMSAT and where they're going. I thought what we would do tonight is focus mostly on the ISS and the ARISS program. And certainly if there is time or there is interest, we can repeat those two topics again. I think the big AMSAT news is that the Gulf T has actually been manifested. That means that they were promised a slot on a rocket, and now they've actually been assigned to a rocket to be able to launch that satellite. And there's some really interesting things on that we can talk about. Go ahead. Basically, ARISS, just to say again, is amateur radio on the International Space Station. We just went through our 20th anniversary of ARISS. The ARISS program, the first contact was made very shortly after the first long-term habitation of the ISS. And in fact, one of the things that you may or may not know is we are the longest continuously running experiment on the ISS. On the ISS, everything is an experiment. And certainly the amateur radio piece is just another one of those experiments. We've just been there for a very long time. Since the program started, we've hosted over 1,300 contacts in multiple countries, and by several people's count, we've impacted several 100,000 individuals over the years. I know we've had several contacts in the Atlanta area there, in the greater Atlanta area, and they've been a whole lot of fun. I thought what I'd focus on tonight a little bit is some of the radios that we've used over the years. We started out, you'll hear us talking about the Ericsson. The Ericsson the first radio is actually a handy talkie. It had 5 watts output, but with a tower that's 250 miles high, you can cover a fair amount of ground with that 5 watts. COL stands for Columbus. There are basically 2 pieces of the ISS. One is operated by the United States and that consortium out of the Columbus module, COL. And the other is operated by the Russians out of the service module. UHF number 1 was a 70 centimeter 5 watt handy talkie, and it did amazingly well again, primarily because of the antenna location. We got our first Kenwood D700. It ran 50 watts in 2003, and boy, was that an improvement over the 5 watt handy talkies. One of the things that we've had trouble with over the years is some programming issues. We try to do all the programming on the ground so that all the astronauts have to do is push the button. In 2012, we went back to another 5 watt handy talkie, the Ericsson number 2. And in 2017, it was another Kenwood. Kenwood has been a very good supporter of us. Most recently, Kenwood donated 10 D710 GAs, and the first one was delivered in 2020. We'll talk a little bit more about those because Kenwood also did some things for us to make them a little more useful. So one of the questions that I always get asked is, where are the radios located? And this is a shot of the International Space Station. Forward is down this long axis towards the top of the screen. Pertinent to what you're seeing here, these are solar panels. These white things, interestingly enough, are for dissipating heat. They can be expanded or contracted as needed to dissipate heat. One of the things that we don't have in space to handle heat is convection. You know, hot air rises. Well, in space, hot air doesn't rise. It simply forms a cloud around whatever is generating the heat, and the heat gets larger. So this is an overview of the space station, and the radios are located in two places. This upper one is in the Columbus module. This is the module that's where our radio is located. And then in the back, if you will, is the what's called the service module. And this was one of the first modules that were put on the ISS. And this is where the other set of radios are located, which are basically operated in the Russian segment. So that's where the two radios are located. I heard you talking about climbing the tower. Well, these shots were taken when the antenna was mounted on the Columbus module. So this is an astronaut. This is a special drill. The drills are very special in that, again, in microgravity, if the astronaut didn't have a good hold and he just used a standard drill, if there was a lot of resistance on the screw, likely as not the astronaut would spin around instead of the screw going into the side of the spacecraft. But when you're talking to the ISS, this is the antenna that you're using. Here is its location on the outside of the Columbus module. It is pointed towards Earth, which is a good thing. It's kind of interesting. We've had some trouble with interference on some of the passes, and someone modeled it out and found out that in this particular antenna location, and with some orbital characteristics, the entire space solar array system comes between the antenna and the Earth. The Russian module, the antennas are clear on the back of the space station, and we don't have that issue, but that's where it's located, there on the outside of the Columbus module. This is what it looks like up close. It basically is a quarter wave ground plane. We use it on 2 meters. We use it on 70 centimeters. And one of the modifications that Kenwood made for us in the D710s is now we can transmit on 1296 with a D710. And so using a diplexer, we're also going to be able to transmit it using a D710. I've actually gotten to hold one of the engineering models of this antenna. And what it is, it's like a very fancy, I don't even want to guess what it costs, tape measure antenna. These yellow things are basically flexible tape measure like material that's covered in plastic. The reason that they made them flexible, it was easier to transport, but more importantly, when the astronauts are doing spacewalks, they didn't want the antenna to be a trip hazard. So if an astronaut, gets tangled up with the antenna just bends and gets out of the way and then springs right back when the astronaut is done. But when you're talking to it, again, it's a quarter wave ground plane. The radials go up instead of down simply because there is no way to really put them down there, but it works very well. That's what you're talking to. Again, having it on the space station at 200 and 250 miles really gives a nice advantage to the antenna itself. On the Russian module, they have a very similar module. It's right here on the surface. There are actually 7 of them back here. And this just happens to be one of the 2 that we use. This is actually a Russian cosmonaut who's working on it. And as you can see, their spacesuits are a little different than our spacesuits, but they both do the same thing. They provide a habitable environment for the astronaut or the cosmonaut when they're out doing their work. This is what the entire system looks like that we sent up to the ISS. That is a D710. You'll notice all the cables have been covered in a special flame-proof covering. Preventing fires on the ISS for obvious reasons is a really big deal. So the radio body itself, the head, for those of you who are familiar with the D710, the microphone with its special cable, and then this is the power supply that we had to build to support it. More on that later. Now, knowing what you're looking for, this is the inside of the Columbus module. And if you ever take heat from someone in your family about how messy your shack is, this is the inside of the Columbus module. Notice this is we don't know what he's doing, but this is an astronaut, we believe, who is working on some kind of a virtual reality experiment. Notice that there is equipment on all 3 walls. There is no really up or down, and so stuff is just stuck on with Velcro wherever there's a space for it. And of course, the question becomes, where in all this stuff is our radio? Can anybody spot it? Well, there it is right there, hanging up on the, I would say the wall, but on this vertical surface, whichever it is, with the power supply behind it. So that's where the radio and the power supply are located. Basically, the recent history on all of this is the Ericsson VHF became very unreliable. For those of you who've witnessed a school pass, they last about 10 minutes. They're very difficult to reschedule. Astronauts are scheduled in 5-minute blocks of time, and getting astronaut time is just really, really difficult. So we switched to the Ericsson UHF, the 5-watt, 70-centimeter radio, and that worked okay for telebridges. We have 12 stations around the world that are very well set up and equipped to handle this. We have not used UHF on the schools just because that brings in a whole nother level of complexity. Having done that for a while, we then switched. We got permission from Sergei Sambarov, who is our liaison into the Russian Roscosmos, the Russian space agency. We got permission to use the D710E on the service module. So now we've gone from 5 watts on 70 centimeters to 2 watts on 2 meters, which is really great, except that everything had to be scheduled twice. It had to be scheduled once with the US payload planners and once with the Russian payload planners, which was just a very large challenge. So with that along comes what we call the interoperable radio system. It is the new Kenwood D710Gs with modifications. Modifications such as I said, the ability to transmit on 1296. The memories have been changed such that the radio remembers to go back into whatever mode it was on when it was shut off. All the changes have to be done by the astronauts. So we spent a lot of time making things such as changes in modes, changes in bands, able to do with 1 or 2 pushes. The new radios, they are 13.6 volt radios, needed a new power supply. One of the challenges that we have to deal with on the ISS is, remember, there's 2 segments, the US segment and the Russian segment. They run on different voltages. The US segment runs on 120 volts DC. The Russian segment runs on 28 volts DC. And so we had to come up with a power supply that would work with either input voltage. The other problem that we were having with the ISS is sometimes, if you remember 3 years ago, the radio would be down for no apparent reason. The reason the radio was down is the ISS is well beyond its original design lifestyle. And much as my ham shack, they ran out of plugs. So that every now and then we would be off the air because we had to be unplugged so that some other experiment could be plugged in. So starting in 2010, we kind of recognized this, and we began to develop and design a new power supply that would handle both 28 volts DC and 120 volts DC and turn them into 13.6 volts. We also, while we were at it, looked at all the things we needed to be able to handle from the amateur radio perspective. There was a ham TV system with a camera on it. There was a S-band beacon module that we wanted to put on. There were just lots of other things. And so we tried to spec it up to be big enough to handle everything that was up there. About 2015, we'd come down to a power supply with multiple inputs and then multiple outputs with pass-throughs as well, so that if somebody needed 28 volts, we had a plug on the system for 28 volts and another plug for 120 volts. So we wouldn't have to be unplugged. We could simply pass some of the power through to whatever was needed. One of the things we learned the hard way was there are not, as you can well imagine, there are NASA standards for everything. So when the first power supply was built, we put on the standard amber and red lights. You know, it's red, it was turned on, and when the red was off, it was off. Well, it turns out that a red light on the ISS means this is a total emergency. Drop everything you're doing and figure out why this light turned red and come over and take care of it. So what we had to do was go back, reorder parts, and turn everything into either green or amber. And kind of, you know, it's a trivial thing, but nonetheless, it's amazing how long trivial things take, because we're building 10 of these to get the power, the lights the right color. In 2016, we finished the first breadboard, and that's what the inside of this thing looks like in breadboard. Needless to say, there's a fair amount of work involved in taking two input voltages and turning them into 13.6 volt DC at reasonable current output. While we were at it, we also put a couple of 5 volt ports in here for USB or for things that needed to be charged from USB. And so this was a major milestone when we got the breadboard done and everything actually worked. There are a couple engineers, Kerry Banke out in California and Lou McFadden in Florida, who are the primary leads on this. Lou is an interesting guy. Lou has either built or been part of every piece of equipment that has ever been flown for hams, starting with the space shuttle. I don't know if y'all know this, if any of you had the opportunity to talk to the space shuttle, the antenna was actually a little loop that they just pasted up inside of the window and hooked it up to Owen Garriott's handy talkie. And if early on, if you were talking to the space shuttle, that's how you were doing it. As we went along, we realized we needed more power. The design was upgraded from 150 watts to 300 watts. In the production unit, there are 9 custom printed circuit boards, 111 different electronic components with 483 components per unit. So there's just a lot of things there. I know some people a while ago were saying, well, why can't you just, you know, get a power supply up there? And the answer is it's a little more complicated than going down to HRO and buying a new Astron to put on the system. And this is one of the things that made it difficult. This took months to close to a year. Everything that flies on the ISS has to be flight certified. And there are a number of certifications you have to go through. You have to go through a heat certification to make sure that it doesn't get too hot. You have to go through a sharp edges certification to make sure that there's nothing that an astronaut could get their finger cut on if they were running it over the surface. This is for an electromagnetic interference testing. You have to certify that when you turn on your power supply, you don't interfere through electromagnetic radiation with everything else. You'll notice that these cables are all taped down kind of in normal configuration, and the chamber they're in is set up to make sure that there are no reflections. Another certification that we had to do was we had to get all the labels certified to make sure that the labels were NASA standard. It just is a very long and arduous, and actually this could have been the most expensive part of the project. We actually did a lot of this testing ourselves, but that's another thing that just takes a very long time. And this is a picture of flight unit number 1, which was ready for shipping to JSC, where it was packed into the SPX-20 launch, which is much like the one that we were talking about this morning. This was another space sense launch of a cargo vessel. We did put on the side of it, if any of you were on here, the names and call signs of anyone who donated to it, as well as the folks who were very much involved in the development and building of the power supply. Then came the night of the launch, and it was a night launch. It was really exciting. I personally thought the coolest thing was watching that stage 1 booster re-land. I mean, that just to me is incredible. One of the things I learned from this launch is if you're ever invited to watch a launch of a rocket and you have to fly there to watch it, do not buy non-refundable tickets. Because you see, the first night that we went down to watch it, we were canceled because of weather. And the new launch date was a week later. Well, I didn't want to stay in Florida for a whole week at that cost, so I came home. So I got the privilege of buying 2 airplane tickets to go to Cape Kennedy to watch the launch. But it really is an exciting thing. And if you ever get a chance to do it, I would really suggest that you take the opportunity. There's a lot of rumble, a lot of roar, a lot of light. And like I said, for me, the cool part was watching that stage 1 booster come back and land. That was just, it's really amazing to me that they figured out how to do that. The radio was activated by Chris Cassidy, KF5 KDR, on the 2nd of June, and the first contact was at 102 UTC on the 2nd of September using crossband repeater mode. And that's one of the things that is new to this new radio, is we are able to run it, as I'm sure many of you know, as a crossband repeater, 2 meters up, 70 centimeters down. And it seems to be very, very popular when running in that mode. So we were up and running and everything was going well, and there was not a problem. And then all of a sudden, after a spacewalk, the radio didn't work. This piece that's over here in the big red box is something called Bartolomeo. And this is a project of the European Space Agency, where they're going to be able to put payloads outside of the ISS. Some of these payloads require RF. And so what they had to do was switch out a new cable through a spacewalk to allow Bartolomeo and the ARISS antenna to connect to the inside. As you can imagine, through hull connectors are a really big deal, and there aren't very many of them. The one that we were connected to has 8 pieces of coax inside of it with 8 connectors. And it actually goes through multiple junctions between us and the radio and us on the antenna. Well, if you can imagine, with 8 pieces of coax all coming down to the same connector, I can't do the math on the number of opportunities there are to get one of those switched. And so you're not hooked up to what you think you're hooked up. And from the inside of the ISS, we did everything we could think of to try and figure out how we were all hooked together. There isn't a lot of test equipment on the ISS, at least for this kind of thing. And if there was, it's not clear that there are procedures on how to use it. So what we ended up doing was waiting for the next spacewalk, and on the next spacewalk, they took off the new cable, put the old cable back on, and we were back on the air. If you want to see a detailed technical explanation of what was involved in all the interconnects and see what the inside of a connector looks like, that's about the size of a small coffee can, that has 8 coax connectors all push on inside of it. If you go to YouTube ARISS Live, and there's a playlist called About ARISS, and you open the news conference, it's about the second or third one down. You will walk through in detail exactly what was going on there. It really was kind of a fascinating story to get that all figured out. But again, we're here. Bartolomeo is here, and the connectors somewhere in this region in here. It's interesting. I watched that spacewalk. I don't know, some of you have, and when astronauts move up and down the side of the ISS, they don't move, they translate. They translate to a new position, which it's a whole nother, we think hams have our unique language as well. They do as well. So Kenwood operating modes. For school contacts, we use FM at 25 watts on 2 and 70 centimeters. I don't know if any of you have worked the APRS repeater, but that's a fun thing to do. It is, again, 10 watts on 2 meters. It uses the standard APRS mode, and it is possible to make contacts on it as well. For the crossband repeater, it's 2 meters up, 70 centimeters down, FM at 5 watts. And to be soon, it will be 23 centimeters down, 2 meters up, or 23 up, 2 down, again at 5 watts. And we're getting very close to being able to do that. One of the things, some people right now, there's this tension between crossband repeater and APRS. Each group thinks we should leave it on longer for them. One of the things that I think most folks don't realize is all mode changes have to be made by the astronaut, which means that we always have to tie a mode change to the end of a school contact. The standard plan right now is to try and leave the crossband, to switch a month in APRS, a month in voice repeater. For field day, we have decided, and we have ARL and AMSAT agreement to leave the ISS in voice repeater mode. And the ARL has agreed that in voice repeater mode, since it really is just a bent pipe like all the other satellites, you can count a contact on the ISS as a satellite contact if you're looking for those bonus points. It's on voice repeater now. It will stay on voice repeater till field day. If you want to do that, my recommendation is you practice a little bit. It is doable with an aero antenna and a 5-watt signal, be it 2 HTs, something like a D72. You really do need to be able to use full duplex. Some folks are using a 2-meter handy talkie for the uplink and an SDR receiver for the downlink. So there's lots of ways to do this, but we will be in voice repeater mode for a field day. Some activities require that we always shut down. EVAs are one. Why EVAs? Well, particularly if it's a Russian EVA, I don't know the exact frequency, but their spacesuit communication frequency is about 136 megahertz. And so we don't want our stuff interfering with potentially with any EVAs that are going on. And again, some docking and undocking activities require us to turn off the repeater, the radio. This just makes the point that I made before. This is a picture of an actual astronaut schedule. And if you look closely, you'll notice that they're scheduled in very tiny blocks of time, 5 minutes, 10 minutes here. So it's very difficult to do it. It is worth noting that all the astronauts are licensed, but they all volunteer to do this. So to thank you for them for being willing to do that. I don't know if any of you have copied the SSTV signals that we're sending down. If you haven't, that's a really fun thing to do. Right now, it's all being done out of the Russian segment. The format is PD120. The downlink is 145/800. They're always doing it at 50 watts, and there are 12 pictures in sequence on 2-minute intervals. There is a URL here, spaceflightsoftware.com, where all of these can be uploaded. It doesn't take a fancy system to do it. John Tramontana, some of you may know him from the NARFL Club. John tells the story of the first time he did this, wondering what his neighbors were thinking as he was out there in his pajamas with a little arrow antenna and his handy talkie and a tape recorder held up next to the speaker on the handy talkie, which he then took into the house, fed into one of the free software programs that you can get on the web, and there were pictures. And this is what the pictures look like from some of the previous missions. Not always totally noise free, but it's really, really interesting. We have over 10,000 images in the gallery that have been downloaded by other people. We have another SST event coming up, probably early July. It's still a little bit in flux, but I would encourage you to consider doing that, of trying to download those images. And the challenge is to try and get all 12. These events last long enough that with a little bit of luck, you can download all 12 of them and then get them on into the gallery. What are the other things that we're going to be doing with the eye, and why are we doing? Well, one is we are working on, as I said, a 23 centimeter project to use a diplexer to be able to use 2 meters and 23 centimeters. ARISS Pi is in development, and that is using a Pi to control the unit, to control the radio from the ground. We can't do total control, but we can certainly be much more flexible about changing modes or changing bands or those types of things. We are looking at doing ground-based SSTV, which I think might interest some people. For qualified stations, what will happen is we'll put you in the network. We'll give you a confidential 70 centimeter uplink frequency. There'll be the standard 2 meter downlink frequency, and you will be allowed to upload SST images, TV images to the ISS through the crossband repeater and back to ground again. That should be a really interesting challenge for those of you who want to take it on. The challenge on 70 centimeters, if you've ever been up there, is Doppler, which is plus or minus 10 kilohertz as the ISS approaches and goes away. So it's going to take a little bit of work to hold that frequency stable enough to get an image up. That's one of the reasons we're thinking for this, we should probably use something like Robot 36. It's just a faster transmission, which means there's less time for the frequency to change. If you do want to work the crossband repeater, please use the lowest ERP possible. We're finding that people running 5 watts into a 7 dB gain antenna, which is something like an Arrow with 25, that gives you 25 to 30 watts ERP, is more than adequate. Always use full duplex. If you don't hear yourself, don't transmit. Be kind and courteous to the others. One of the things, and maybe it's just because I'm getting older, older ears appreciate it if there's not a lot of fast talking. You know, some people, well, I don't even know if I can do it. K7SYS and 18. It's so quick that you end up actually doing more repeats as people try to figure out what you said. But it is again a lot of fun, and these days of low sunspots, it's another way to play radio with not a lot of expensive equipment. As we look to the future, you may know this, NASA is putting together a project called Lunar Gateway. Lunar Gateway is to put a small spaceship in orbit around the moon. And we have been invited, primarily because of our current interactions with NASA, to be part of that project. It's called the Amateur Radio Exploration, the ARISS project. There'll be 3 segments in it, one for education and amateur ops, one that will be a space segment that will be crew tended, and another one that will be autonomous. And then there's obviously some operational control. That is one thing that makes this a little different. As presently envisioned, crew will only be present on Lunar Gateway for about 2 months out of the year. So the rest of the time, whatever we do, we're going to have to be able to do ourselves. The other thing that I'm kind of intrigued with is we are going to be using S-band and C-band for uplinks and X-band for downlinks. I know one of my frustrations, because I kind of like playing with microwaves, but one of my frustrations down there and actually up here, all the microwave activity here is on the other side of the Cascade Mountains over in Seattle, was I didn't have anybody to talk to. Well, this will give you a new target to be able to work with the microwaves on S-band, C-band, X-band, and then there will be mixed use. There'll still be a 70 centimeter capability, but this is a real exciting project. I used to know some dates. I'm not so sure of those dates anymore. With the change in administration, there's always, every time the administration changes, things shift a little bit. The project is still on the plate. What's a little different is all of the lunar-based projects are being pulled together into a single project, and that's still being worked through about how that works out. But suffice it to say, I think the good news is there will be a presence around the moon, and we will be part of that. The other thing I think that'll be very interesting, there was an allusion made earlier on to the fact that I've started to play around with EME a little bit. This isn't going to be dependent upon what you can reflect off the surface of the moon. This is actually talking to another radio with transmit capabilities to send much louder signals back down to you, which I think should be very, very helpful. The crew will be involved with school contacts, SSTVs, experimental, and hopefully random voice contacts. Every now and then we get an astronaut who really likes to do it, and we actually have some random voice contacts. Doesn't happen very often, but that is being a little better built into the lunar experiment. Then the autonomous activities, there will be another voice repeater that you can use again through that. The ability to command robots via APRS, all of that should be available and lots of fun. The last thing I would just say on this subject is none of this comes for free, particularly when you're having to buy space rated parts and cables and everything. For the present IORS voice repeater, I always like to think of a donation to this as just paying the repeater fund. You can donate at ARISSUSA.org. And this little guy here is one of the reasons we kind of do all this. He was asking his question of an astronaut, properly garbed. So that's it for the presentation. Questions you might have about what's going on with AMSAT, or I'm happy to take any of them.
John, this is Brian again. With the recent decommissioning of the AO91 and the AO92, is there anything in the works for either replacements or recommissioning of existing satellites that are nearing the end of their experimentals?
Yeah, my understanding is that the current satellites, if you're speaking of AO1, AO92, the problem they all had is they've run out of battery. And that's kind of hard to fix. Oh, we keep hoping that we'll have an AO7 style miracle where one of those batteries will short close, and when they're in the sun, they will come back on again. AO95, we don't sure why, but it just can't hear. And so it's stuck in safe mode. For those of you who've listened to AO95, you might hear a Veronica every now and then. Veronica was Lou Matero's daughter. And for all the Fox satellites, she recorded a hello, this is AO91 or AO92, and you might hear her voice from now. But beyond that, I don't know. I'm not aware of attempts to refurbish satellites. As I said, Golf T has a launch date, or at least a launch manifest, no date, but a manifest. Golf T is actually an important project in that it tests a number of things we need to go to higher Earth orbit. It tests the ability to be steerable. It tests the high gain antenna. It tests expandable solar cell panels. The challenge that we're dealing with when it comes to higher Earth orbit is governments have been concerned that there is so much stuff up there that if you go into a higher orbit, you have to demonstrate a capability to be able to deorbit your satellite at end of life. So at least from the US side right now, the answer to your question is one of the reasons we chose to leave the ISS in voice repeater mode. It becomes, along with SO50, another potential FM bird that people can use for field day. Other questions?
There got to be questions out there.
Well, I don't want to take them all.
Go ahead.
The other birds that are up there, John, with that's in relation to the single sideband. Since we have lost the AO91 and 92 and are intermittent if they do come online, and the SO50 is hit and miss half the time, are there still functioning single sideband birds that can be used on the amateur side?
Yes, there are actually a number of single sideband birds. It changes a little bit, but if you go to, hang on here just a second.
Yeah, I'm trying to pull up my.
If we go to satellite status, let me go back to screen share here.
I've got several of them put in my computer that I was trying to do from winter field day.
Everything that is in blue on this screen is a functioning satellite. AO7, we all know, is kind of hit or miss. This is the big series right here. The XWs, these are all Chinese satellites. RS-44 is Russian, CAS-4A and 4B, and there are two more members of that family that are either about to be launched or have been launched and are being commissioned. But there are a number of good sideband CW satellites. RS-44 in particular is one whose orbit is a little bit higher, and people in your position in the East Coast have actually been able to use RS-44 to work into Europe. So that's a really good one to remember.
Okay, because I know most of our guys here, they've been trying to use the phone birds. That's why they were looking at some of the single sideband ones, because they're trying to use those, and I've been trying to verify whether or not they're working. And with the issues that we had during winter field day, I didn't get a chance to try them.
Yeah, no, any of these that are in blue are working. And like I said, XW2A, they're not all on all the time, but that series is a good series. My favorites were always CAS-4A and CAS-4B. When I was back your way, my antennas were really just two egg beaters, and I did very well with them. I had to be a little bit patient, but they worked just fine. I ended up, I think, with 172 grids on egg beaters. So it can be done.
Yeah, I've worked them off of a vertical before, so it's kind of fun doing it off of a vertical.
Yeah, I bet it is.
You know, you got to time it just right when you can just start to hear the station coming in, you know, to be able to do the transmit because it fades in and out. So for those thinking you have to have an arrow or, you know, some type of a Yagi, you can work them off of a vertical. You just have to play a timing game.
Yeah, Bob Berniga did some interesting work for the Navy, and he was able to show that if you take a Yagi and you mount it fixed at somewhere between 20 and 30 degrees of elevation, you will get 60 to 80%, depending where you are, of passes of the satellites as they go by. You don't really need a full Azel rotor system to be able to use them.
That's interesting.
I would encourage you all to give it a shot. It's a lot of fun. And like I said, it's one of the things that's kind of kept me going when there just aren't a lot of sunspots to play with. Although I can tell you from the West Coast, it's a lot easier to work China than it was from the East Coast. On the other hand, from here, it's a devil to get into Europe. So there's no free lunch. Other questions that people might have?
John, hey, it's Rob. Let me. Somebody tried to actually donate to ARISS now, and they said on the chat that the donate link is broken.
Okay, that's good to know. I didn't know that, but I will report that back and get that fixed.
And it's encouraging that somebody actually tried.
Yes.
Can you do just a quick overview of the amateur satellites? You're throwing out satellite names and such. And a lot of us know about, well, I'm gonna take us out of it. A lot of people know the word us. A lot of people know about it, but there are probably a lot of people who don't. So just
okay. Well, there are a number of satellites that have been launched. They all have a name. They all are supposed to be frequency coordinated. For those of you who run the repeater, I think you can understand that frequency coordination doesn't always work out quite as well as you thought it would. They were all and then they're all given a name. And they also have numbers, which are kind of obtuse, that are assigned by NORAD. But the names are things like XW-2A. That is part of a group of Chinese satellites that were launched and have been actually operational for some time now. The place to go to find out what's up there is if you go to amsat.org/status, you'll see a list of all the operating satellites. And if you can still see my screen, can you? Yes. Anything that has an underline on it, if you click it, it will take you to a page that explains the satellite, what modes that it works, and all of those. These are all what are called linear transponders. An FM satellite is literally a repeater in the sky. One uplink, one downlink. Almost all of the FM satellites use a PL. I think I can say now all of the ones that are operating use a PL of 67. Don't forget that on your uplink. I've done that more than once and then wondered why I couldn't get in. But it is a single frequency, one signal in, one signal out, and being FM, the big dog wins. The sideband satellites are what they call a linear transponder, and they take a chunk of spectrum anywhere from 20 kilohertz to 100 kilohertz, and you can have multiple QSOs going on at the same time. Once you get your radio dialed in, I'm thinking of sideband here, and if you have Doppler tracking, having a sideband QSO over a linear transponder satellite sounds just like having a sideband QSO on HF. By tradition, all the linear transponders are lower sideband up, upper sideband down, because it gets flipped in the process of being translated. that's kind of the difference between the two. And the names are just assigned by international agreement. Some of the ones you can guess, RS, anything with an RS in front of it is a Russian satellite. SO, which is a little hit or miss. SO-50 is a very old satellite that was built by the Saudi government, Saudi Oscar. Oscar was what you may remember if you were around for Oscar 1 or Oscar 2. Oscar is the acronym for Orbiting Satellite Carrying Amateur Radio. This is an FM satellite, and when it's operating, it's very good. It's been up there forever, a testament to being built by a government having access to lots of money and good parts. The thing that degrades a lot of the satellites, there are two things. One is batteries run out. Number two is every now and then they take a cosmic ray hit, and that can really mess things up. Did that kind of answer your question, Rob?
Yeah, it did. One more, operating from the ground, as you said, I think it just takes two radios, one for up and one for down, and
Yes.
and antennas, right? And to know where the satellites are.
And to know where the satellites are. And to know where the satellites are, there are lots of ways to do that. If you have a cell phone, I use AMSAT Droid in the Android world. There is at least one complementary Mac operating a type operating system one. They can tell you where they are. Another place you can go is to AMSAT itself. Plug in your coordinates and the satellite you want, and it'll tell you the next 5 passes. One of the things I do recommend if you want to try this is the first few times you do it, take a couple of road cones or lawn chairs or something and put one where you expect the satellite to come over the horizon, AOS, and one where you expect the satellite to go over the horizon the other way, LOS, loss of signal. That at least will define for you the range in which you should be pointing your antenna. Because when I started doing this, I didn't do it. And if I didn't hear it, I mean, I looked like a crazy guy. Well, maybe it's over here. No, maybe it's over there. No, maybe it's someplace else. I think that would be it just helps with the operations to set some limits as to where it's going to be.
Yeah, tonight at 9:15, you'll actually be able to see it pass over.
Yeah, actually a couple, 3 nights ago, we were making a contact with a school in France using a ground station in Portland, Oregon. And so it was really cool because not only could I see the ISS, but I could hear Thomas Pesquet, the French astronaut who was talking. I could hear him talking, and that was a real treat, was to be able to see it and hear it at the same time. That was pretty cool.
Yeah, I think email got sent around to several groups about that. But yeah, whoever has not seen the station, it's really cool. It's a dot that looks like a star, but it's smoothly moving across the sky, and that gives you an idea when you're on the radio, that you'd be tracking it, just holding an antenna up, keeping it aimed at where you normally wouldn't see the dot, but where it's going to be.
Indeed.
One quick thing.
Well, the other thing that I noticed, sorry.
No, go.
John, on your going back to those that are probably going to use like an arrow antenna, what I found is when doing slow scan TV is I actually have to rotate the arrow just a little bit towards the left to get the signal to come in clearer. For those that are doing the hand captures, not just pointing that direction with the vertical or with the 2-meter verticals up and down, try rotating your antenna a little bit left or right with your wrist and change the orientation.
Yeah, no, that's a really good point. What you're doing when you're rotating your wrist is you're getting your antenna aligned with the apparent plane of the incoming wave. The other thing, if you're using an arrow, is when you go from receive to transmit, you need to just flip your wrist 90 degrees to put the 70 centimeter transmitting elements in the same plane as the receiving elements, whichever way it is, 70 or 2, but always flip your wrist to get the transmitting in the same plane that you found was optimal for receiving. Now, that's a really good point, Brian.
Yeah, that's what I found doing slow scan. And one of our members down here in Florida got the bug. He's actually made several contacts over his Arrow 2 with an HT. And that was one of the comments that I told him is make sure you rotate a little bit when you start to hear them come in, rotate and find where that needs to be. And then you know about where your angle has to be, you know, when you're tracking it. But he's made several good contacts over the ISS crossband. He's made a couple of APRS, and he's done a slow scan. So a couple of our members down here have gotten the bug per se. But that's something that I've always brought up to our guys when they want to try it is, you know, experimentation is key.
Yep.
You know, always listen first.
Very good. Excellent points. Well, if there are no other questions, I thank you all for having me tonight. I hope that was useful. If nothing else, I think those are fun pictures to look at. I do show my wife every now and then the picture of the inside of the Columbus module when she is getting a little excited that I have too many wires hanging out of things. It could be worse, dear. So anyway, with that, Rob, back to you.
John, thank you. Thank you so much for the presentation. I'm surprised there weren't more questions about from people there. Let me just throw two more quick ones in there. DMR, are you looking at DMR on any of the platforms?
We have not looked at DMR yet. I think the question that I would have on DMR, and maybe some of you who are DMR experts could answer it for me, is how tightly must the base frequency be controlled on DMR? Because we always have to contend with Doppler on the ISS. It's plus or minus 3 kilohertz at 2 meters. It's plus or minus 10 kilohertz at 70 centimeters. So that's a good question. And I'd be curious to know if anyone could give me any insight on that.
Yeah. Go ahead, Jeff. Don't just put it on chat. Say something.
I'm sorry, I'm working at the same time, so it was just easier for me to type. No, I mean, it's got, I mean, you're dealing with a 12 narrowband FM, but then dividing that 12.5K by 2, because you've got 2 time slots. So you really only have 6.25 kilohertz to play with. I don't think it's going to be anywhere near as forgiving as wideband FM is.
Yeah, but that's a good point. I mean, it's something though that we should look at it and we should think about, because I know there's a lot of interest in DMR.
And there's D-Star 1, right? I mean, that's been up there for a while.
Yes.
I haven't heard that one. It's on my list, but I mean, it's I don't know if that's 12.5 or 25. I don't remember.
Or that, oh, wait. John, when the 1296, are there radios, 2 meter radios? I guess I know the ID1, I guess, is, but that's D-Star. You know, are there FM 23 centimeter radios out there?
There are FM. In fact, there are several new ones that are out there, because I've been looking at them, but right now I can't think of them. But there are 1296 FM radios out there.
That would be pretty cool. And lastly, unless someone gets in there, I know we're about done. One of the passes where they were sending the slow scan down. I actually, I wanted to check it out, and I've got a J pole, and I was curious what happened, and what happened was as it came up over the horizon, I started getting signal in, and the screen started painting, and as it got directly overhead. It went out for, because there's no pattern directly overhead. And then it came back and kept painting. I guess, I missed some of it, but it came back after it crossed overhead and then until, it went down LOS.
Yeah, you'll see that, and you might have seen that in some of the images I showed where the program on both ends keeps marching along. And with a J-pole, or I've also done it with the vertical. With the vertical, I have the same problem. If you think about a vertical pattern, there's a null when you're right smack dab overhead. Sometimes we see that when they actually with the downlink signal every now and then. In school contact, someone would drop out right in the middle of the pass, and we went, well, why is that? That's when they should be the loudest. And what was happening was a vertical, if they were on like an egg beater, the vertical antenna on the ground was pointing directly at the vertical antenna on the radio, and so it was null to null, and that's where you got that little dropout.
That was fun. I got it was one of the passes where I just got a big the Russian call sign and a picture across the screen.
Yeah, it doesn't take much, particularly when we're doing it with the Russians and they're running 50 watts. I have successfully downloaded literally with a handy talkie and a rubber duck. So it doesn't take much antenna to on a good high pass with 50 watts up there to be able to get an image.
Don't discount the tape measure Yagi. I actually had better results on my tape measure Yagi than my Arrow.
There you go.
So, and also Arrow isn't the only way to go either for handheld. So Elk makes an excellent log periodic that will do.
Yeah, I've used the Elk. The thing I liked about the Elk, because I actually own them both, the thing I like about the Elk is it's flat.
Yeah,
It's much easier to throw in the car.
Absolutely.
And you don't need a diplexer, so you can run more power if you want to. Absolutely.
I think it's better antenna personally, but the Arrow is just kind of the gold standard.
Yeah, we're going to have some kind of hands-on, the ARC hands-on, so that we can actually start playing with and showing people, that it's easier to do than you might think. We'll do that sometime. And next year at the Hamfest, John, you'll certainly be invited. I don't know how often you get back to Atlanta.
I would love to come because, like I said, I know don't move in the middle of a pandemic. With everybody locked down, it's really hard to meet anybody new.
That's true. Everybody's inside. But I don't know if we'll be able to fly you down, but we're definitely going to invite you.
You go ahead and invite me. I'd love to be there.
Thanks, John. I guess nobody else. I'm surprised. Okay. Thank you, John.
You're welcome.
Great night.
Thanks, John.
Thank you. All right, guys. Thanks, Rob. And thanks, John, of course, for another great presentation. I don't think we have do we have anything on the schedule for July yet? Or are we still working on July's program?
July is going to be on USB. It's going to be USB, some technical aspects of USB, how USB works generally.
Upper sideband USB or universal serial bus?
Thank you for that's a good question. Good question. Yeah, it's going to be
appropriate.
The USB connectors. Yeah, that's right. The USB connectors and how your radio connects to digital. Radios use USB to connect to computers when you're doing digital, and the different radios need different types of connectors and different types of settings and things like that. And he's going to talk all about that. So it's how you get your radio connected to computers and how the whole thing works. And I learned a lot about USB and just in general. It's something that we see a lot. The USB connectors all over the place, and so that's going to be July, and that should be another good one in our series of good ones. One more, John. What about Field Day?
Yeah, one real quick update for everybody runs. I'm going to draw a ticket here for the $25 gift certificate to HRO, and our winner tonight is Brent Baxter. I didn't get a call. Are you still with us? I don't see him with us. Nope. Okay, we'll draw again. How about Rob, or I'm sorry, Bob, AA6TB? If you are there, I'm looking.
Yep, I'm still
Oh,
here.
there you are, right there. All right. I'm making a trip to HRO in the morning, so I will have them add $25 to your account there at HRO that you can use at the Atlanta store. So congratulations and thanks for attending tonight.
Well, thank you so very much. This is an excellent presentation, and thanks, John.
Okay. So you'll be able to use that without having to carry that certificate in. It'll be underneath your call sign. I'm assuming your address is correct in QRZ.
That's correct. I'm up in
Okay.
North Carolina.
Gotcha. Oh, you're in North Carolina. Okay. Well, I think you can use it for things to be ordered from the store. I think it just has to be done at the at that particular location. So if
Right,
there's
again,
a problem,
thank you so very much.
yeah, if there's a problem, I'll let you know. If that's not going to work, well, then we'll just send you a $25 gift certificate or something. So thanks.
Thank you so
Thanks
much.
for being with us tonight. All right. Yeah. One update for tonight, club-wise, is we are doing field day. We're still putting that together as far as exactly the exact location. We're expecting to be out at Brook Run in Dunwoody, Georgia, up off of North Peachtree Road. We know that much. We just don't know exactly where in the park yet. We're still putting that together. So hopefully the next couple of days we'll have that finalized. It'll be an all-day event on Saturday, and then we'll call it a night on Saturday evening, and when the park kicks us out, and we'll let you work from home. This year, of course, like we did last year, you can work from home and give the club credit. So look on the website, atlantaradioclub.org.com, and there'll be instructions on how to where to join us and how to give the club credit if you're doing it from home. So, and we'll also post that on our Facebook page too. So please do join us if you can. It's a lot of fun. Brook Run's a really nice little park. It's easy to get to off the interstate, and we should have a good time on Saturday. And like I said, if you can't join us, no big deal. There'll be a way for you to do it from home. So please do have fun with field day this year. It's quite an event. If you're afraid to get on the air, just get on there and have at it. Make the mistakes. Nobody's going to kill you for it. So that's the way you learn and get rid of the stage fright you might have or mic fright. But do give it a shot. Like I said, there's no Hamfest this weekend. We will be back in 2022, same weekend, the first Saturday of June every year. So continue to look for updates on that throughout the rest of the year. And I don't have anything else. And Stephen gave a repeater what he needed to give up to any of the officers that are present have anything to say, or does anybody have any questions for anybody in the club? Any questions on anything you've been wanting to ask, or heck, even if it's a question that might not be club related, if you want to ask somebody while you've got close to 40 people in the audience. Any questions for anything? That last second satellite question, maybe? Nope.
Let me put in a plug for field day.
Okay.
I guess I'm okay. Field day, it's a contest. It's an ARRL. It's a contest, pretty much, but it's also a chance to be out there with a bunch of hams. What we've always done in all of our events is to get anybody on the air who wanted to be on the air. Even if you're a tech and you don't have HF privileges, you can get on HF because you'll be with people who do. There'll be radios there, there'll be antennas there, and I think as one of our one of the founders of our modern field of our days, Bill K4KFT said, you build a radio, bring a radio, we'll hook it up to the antenna for you if you don't have one. Bring an antenna, we'll hook it up to a radio for you. You need a power supply, we've got that. And we've got, it's just a place to just come out and watch people operate or get on there and operate. We're more interested in getting everybody on the air to just play around than to actually score any points. And you can tell that by the points that we've scored, the small number of points that we scored. It's more of just getting together. So.
Well, I mean, if we made any effort at it, we'd probably beat North Fulton and GARS combined anyway. So.
We get the ice cream.
Well, we would, so. Now our approach is just to get out there and have fun. Certainly the way other clubs do field, everybody has a different way of doing it, and they're all great ways. So we just enjoy and want to get people out, get a chance to get out and get on the air and have some fun. So do join us for that. Any other questions? Any last minute satellite questions? I guess not. All right. Well, like I said, we're going to continue to meet on Zoom for the foreseeable future. Hopefully, we'll get to a point where we can either get back to the Red Cross, or we may have to find an alternative in the meantime, and when we can start having some in-person meetings. We'll continue to try to have some days in the park once a month coming up. So check out July and August as we go along. There'll be some more opportunities to get out there and have some fun. So please do join us when you see those opportunities approach. And if you have some other ideas you'd like to see the club do, let us know so that we can put some things together and get that going. So,
Hey, John, one
Yeah.
more thing. One more thing. This presentation was recorded, and we've recorded all of our presentations since September when we first started doing Zoom presentations. They're all recorded. They're on YouTube. So if you go to YouTube and you look for Atlanta Radio Club, you should see there'll be a bunch of videos out there. Some of them will be that some of our people have added, and it's under the Atlanta Radio Club name. And one of them is we had Martin Jew in there from MFJ, and he did a presentation on the use of his equipment and antenna analyzers that was surprise to everybody. He had all kinds of things, and that's on there. Plus, also all of our monthly Zooms are on there. This Zoom will be on there in a couple of days, and on our website, you'll be able to see where get to the slides. The slides will be there, and the video will be there, and you can check out our other programs. They were all good. So back to Zoom control. Thank you.
all right, guys. Like I said, thanks again for being with us tonight, and thanks for John for joining us for another wonderful presentation. Satellites, I've noticed on a lot of Facebook groups, are really getting a lot of attention lately. So it looks like people are taking advantage of being able to make those contacts through satellites. So keep it up and keep doing what makes the hobby fun. So thanks for being with us tonight, and y'all have a good evening. And if the weather's clear, enjoy the ISS past night. And we'll see y'all next month, July 1st, 7 p.m., same place. Y'all have a good evening.
7-3, everybody.
Thank you, guys.
Thanks, John. Take care. Thanks. Good night, everybody.
And for those that are interested, there's my Amshack.